All right, welcome back. We're going to continue our conversation about dividing polynomials using long division. Today I'm just going to throw a couple more difficult examples at you to make sure that you're getting all the intricacies of long division. So we're going to set them up exactly the same way. Whatever is doing the dividing is going to go in front. Then whatever is being divided goes on the inside. So our process is still exactly the same today as it was yesterday. I need to see what does it take for 2x to cancel 6x squared. Well, for the 2 to become a 6, I'm going to have to multiply it by 3. For x to become x squared, it needs another x. So I'm going to multiply it by 3x. And the I'm talking about is at 2x plus 1. So distribute that through. That gives me 6x squared plus 3x. So that's what I'm going to bring over here and then subtract off to see how close did I get. 6x squared minus 6x squared cancels off. 4x minus 3x leaves me 4x. Then I bring down the 2. All right, same game. Now I need to see what does it take to get the 2x to cancel 4x. Well, this time the x's already line up. I just need another 2. So I'm going to multiply this by 2. So that 2x plus 1 distributed through. That's going to give me, oh, not 4x squared. I'm sorry. That's going to give me 4x plus 2. Subtract it off to see how close you got. 4x minus 4x. And 2 minus 2 is actually gone also. So this is something we didn't really touch on in the last video. But if I'm ever left with 0 there, what that means is that there just isn't a remainder piece. It means I'm actually done as is, no remainder. So all I have left is that 3x plus 2. So let's focus on our next one. So I have 2x minus 5 dividing 2x cubed minus 9x squared. There's no x term, so remember I need to have a 0x there. And 15. Remember, any wholes, any polynomials, need a 0 there to hold that spot. And now I start the process all over. What does it take to get 2x to cancel 2x cubed? Well, the 2's already line up, so all I need is an additional x squared to get the x's to line up. So I'm going to put that up there and multiply the 2x minus 5. That's going to give me 2x cubed minus 5x squared. So subtract off to see how close did I get. So 2x cubed minus 2x cubed is gone. Negative 9x squared minus a negative 5x squared. Remember, when you're subtracting a negative number, it's going to be the same thing as adding. So negative 9 plus 5 is still going to be a negative 4. So I'm going to have a negative 4x squared in this case. Then I pull down that 0x. Now I do the process again. What is it going to take to get that negative, or that 2x to be a negative 4x squared? Well, to get 2 to be negative 4, I'm going to have to multiply by a negative 2. Then get x to cancel the x squared. I'm going to need an x. Then I need to multiply that to the 2x minus 5. Distribute that, so that gives me negative 4x squared plus 10x. So negative 4x squared plus 10x. Let's subtract that, see how close we got. Negative 4x squared minus a negative 4x squared cancels off just like we want it to. 0x minus 10x. It's going to be a negative 10x, and then I drag down that 15. All right, third time. How can I get 2x to cancel negative 10x? Well, to get 2 to be a negative 10, I have to multiply by a negative 5, and the x's actually already line up. So all I need is that negative 5 piece. Then 2x minus 5. So I get negative 10x plus 25. Negative 10x plus 25. So negative 10x minus a negative 10x is going to cancel just like we want it to. 15 minus 25 is a negative 10. So when we get down to that constant, that negative 10, that is going to be my remainder. Again, your remainder just goes over the piece you are dividing by. So it's going to give me negative 10 over 2x minus 5. And then that's going to be the end of this problem. All right, let's do one more, and then we will call it good for this notes, and you can write your summary. So 3x plus 1. I'm dividing the 6x cubed plus 23x squared minus 5x minus 4. I start my process. What can I multiply 3x by to cancel 6x squared? Well, 3 times 2 gives me the 6. Then I need an x squared to get the x to become an x cubed. So I need 2x squared in this case. And I'm going to multiply that to the 3x plus 1 to give me 6x cubed plus 2x squared. So that's what I'm going to put over here. And I'm going to subtract it off to see how close did I get. 6x cubed minus 6x cubed cancels off, meaning it's gone. 23x squared minus 2x squared is going to leave me a 21x squared. Then I pull down my next term. And I continue my process. What can I multiply 3x by to cancel a 21x squared? Well, 3 times 7 gives me 21. X times x will give me x squared. So this time, I'm going to need a 7x. Multiply that to the 3x plus 1, and that gives me 21x squared plus 7x. So 21x squared plus 7x. Subtract it off to see how close do we get. Well, 21x squared minus 21x squared is going to cancel off. It's going to be gone. Negative 5x minus 7x is going to be negative 12x. Then I pull down my next term. So what is it going to take to get a 3x to be a negative 12x? Well, 3 times negative 4 will give me negative 12. Then the x's actually already line up. So I'm going to multiply the 3x plus 1 by that negative 4. So it's going to give me negative 12x minus 4. Subtract it off to see how close we got. Negative 12x minus negative 12x cancels just like we want it to. Negative 4 minus a negative 4 cancels also. So here's actually another case where I have no remainder. Okay, that remainder is 0. So that means the answer, what I'm left with, is legitimately this polynomial right here. All right, so what I've included before your summary is a little comparison of numerical long division with polynomial long division, just so you have a nice little example to see how they are similar. Right, but that is going to be all for our notes today. Just a little refresher, give you a second day working with this long division material. So take a moment to write your summary, please, and then come back to class prepared to do your practice work.